Hey, I was just looking at some old, some inspiration photos for my wedding. I'm marrying a person, not a cat. She's definitely not a cat. Anyway, welcome to lesson 2.6. This is application to coordinate planes. We're going to be looking at two kind of challenging problems. The first one has to do with the ratios. And so if we're going to be looking at ratios today, I should probably do a little reminder of what ratios are. And this is like a typical question you would see in the 8th grade. So the ratio of boys to girls at university prep in the 10th grade is 2 to 3, which means for every 2 boys, there's 3 girls. If there are 100 students in the 10th grade, how many are boys and how many are girls? Well, let me show you how to do this. The first thing you do is add the ratio. So we have our numbers 2. Sorry, I don't even like that color. What am I even doing? We have the ratio of 2 to 3. So what you're going to do is just add 2 and 3. And that gives you 5. And the reason you do that is because there's 5 equal parts, is what it's saying. There's 2 parts boys and 3 parts girls, and each part is equal. So 1, 2, 3, 4, 5. Now this is a crappy looking circle. It's not divided equally, but this is supposed to be a good visualization. If you have a circle, it's split up into 5 equal parts. 2 of them are girls, 3 of them are boys. All right. Now what we're going to do is divide the total by the sum of this ratio. So we're going to do our total divided by the sum. And what that means is that if there's 100 total students, okay, and the sum we found was 5, we're going to divide those numbers and we get 20. And what that basically tells us is that we're taking 100 people and we're dividing that into 5 equal parts, right? Because there's 5 parts in our ratio. 2 of those parts are boys, and 3 of those parts are girls. Now, if I wanted to figure out how many boys and girls there are, well, 2 of those parts are boys, and each part is 20, so there's going to be 40 boys, and 3 of those parts are girls. So each part is 20, so that means there's 60 girls. Another way to say that is to take your ratio of 2 to 3, multiply the 2. We're going to do 2 times the part, which is 20, which equals 40. We're going to do 3 times the part, which is 60. So you just take this number and multiply it by each part. Now if that was confusing to you, that's okay. But basically what you should be taking from this is that a ratio basically splits a total into equal parts, and you just have divide up those parts. So let's take a look at how this applies to geometry. The endpoints of line ABC are A -27 and C 8, 8. Determine the coordinates of point B if AB, the length of AB, to the length of ABC is a ratio of 2 to 3. So here are 2 points. This is A and this is C. We got to put B somewhere on here. So the ratio of the length of A to B to C is 2 to 3. So 2 parts to 3 parts. The way to do it is follows. Watch and learn. Step 1, you still just add the ratios. Alright, we're going to add the ratio. And so our ratio once again is 2 to 3. 2 to 3. So add that up. 2 plus 3, and that gives us 5. Step 2, we have to divide by the total. Divide total by ratio. Now, what does this total mean here, right? What are we even saying by total here? What that is actually is this. It's the total amount of units to get from A to C. All right? And what I mean by this is we're going to count how to get from A to C. Watch and learn. To get from A to C, I go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, let's write that right here. And to get to C, I'm going to go up now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I go over 10 and up 15. So what I'm going to do is take my totals, so over 10 and up 15. I'm going to divide those by the ratio of the sum of the ratios. So it's 10 divided by 5 and 15 divided by 5, which gives me 3. Sorry, that was way off. Such bad math. 2 and 15 divided by 5 is 3. Now what you're going to do now, check it out. All right, you have your totals. You divide it by your ratio. What you're going to do now is go over 2 and up 3. Watch. Going to go over 2, 1, 2, and up 3, 1, 2, 3. That's a point on the line. Keep doing this. Over 2 and up 3. 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 Okay. Got me? Yeah? Okay. So now remember the question says I want a ratio of 2 to 3. So from A to B is 2 and B to C is 3. Now I have 5 parts here. I have 1, 2, 3, 4, 5 parts. I want a ratio of 2 to 3. So it's going to be this guy to this guy, 2 to 3. AB is 2. So that means this is where our B is. See? So AB is 2, BC is 3. If you have trouble with this made no sense, watch it again. Alright? Because all you have to do is add the ratio, 2 to 3, add that together. Find the total distance, over 10 up 15. Divide those by that sum. And, well, you know what? Actually, just rewatch it. I don't know why I'm re-explaining it. You got it from here. Yeah, that's how it's done. Alright, for our second kind of problem, it's a little more straightforward. We're going to prove triangles are right triangles on the coordinate plane. So in the coordinate plane, the vertices of triangle ABC are 0, 3, negative 4, 1, and negative 6, 5, which conveniently been drawn down here for you. Alright, but it won't be there. Prove ABC is a right triangle. Now the way to do that is that we have to find out if there are any perpendicular lines here. Alright? Now if you look at this, you could probably figure out where the right triangle is. Alright? If you look at this, it looks clear that this is your right angle. So if I prove that these two lines are perpendicular, then I know that this is a right angle and it's a right triangle. So those two lines have to be perpendicular. So how do we do that? Well, if we find out their slopes, then we'll probably be good to go. So our first step is going to be this. We're going to graph the triangle and state the legs of the triangle. So we graphed it, and we found that the two legs are this line, CB and AB. So it's CB and AB are our two legs, and we want to show that these are perpendicular to each other. The way we're going to do that is just by finding the slope of each. Okay, so our first leg is CB. Alright, and let's write those coordinates down to make this easier. C is negative 6, 5. B is negative 4, 1. To find the slope, let's just use our slope formula. So since we're good students, we write down the formula first, over x2 minus x1. We'll plug it in. y2 is 1, x1 is 5. B, x1, x2 is negative 4. And x2 is negative 6. 1 minus 5 is negative 4. Negative 4 minus negative 6 is 2. We reduce that and we get negative 2. So that is the slope of CB. Alright? Now let's find the slope of, what's our other leg? AB. AB. Alright, A is 0, 3. B is negative 4, 1. Let's do this out. So we write our slope formula down again. And we get y2 is 1. y1 is 3. x2 is negative 4. And x1 is 0. 1 minus 3 is negative 2. Negative 4 minus 0 is negative 4. Negative 2 divided by negative 4 is 1/2. So look at that. 2, negative 2, and 1/2. Well, sure enough, those two slopes are perpendicular to each other. Since we know that these two lines are perpendicular, this must be a right triangle. We did it. Now, the most important part here is to write your concluding statement, okay? And the way you're going to write that is this. The slope, so you just write the slope of each line. The slope of CB is negative 2. The slope of AB is 1/2. So just state what you know, okay? And your conclusion is, since CB is perpendicular to AB, since these two are perpendicular to each other, we know that triangle ABC, so triangle, I'll just write it out, ABC is a right triangle. It's really important you write your conclusion here. On the Common Core, there's a lot of explaining, and so you have to explain what you found out. So you found the slopes of the two lines, you found that they were perpendicular, and so that must mean that this is a right triangle. Alright guys, brush your teeth before going to sleep, or else you'll smell funny every day. Trust me, I would know from high school.